This is part 6 of the Athol 644.5 Swivel Jaw Swivel Base Vise Rebuild series. If you haven't seen part 5, click the link at the top of the screen. In this video, we will be fabricating the taper pin that locks the swivel jaw in place. Hello everyone, I'm Jeff and welcome to my shop. We got a lot to cover, so let's get to it. So this is what remains of the original taper pin, and from this and the vise itself, we can deduce a couple of things. Some tapers are standard, but the majority of them, the taper, the angle on the taper actually changes depending on the length of the pin. So here we have the patent drawing, and you can see the original locking taper pin there, figure number 6. And we're going to try to recreate something similar to that. So this is the measurements that I came up with, and this is using the original taper pin as well as the bores that are in the swivel jaw and the base or the vise body itself. So here we are on my lathe, and I've got it set up for roughly a 3-degree angle. There's a lot of formulas you can use, and there's plenty of videos on YouTube on how to turn tapers. But at the end of the day, I just relied on the Mark I eyeball. So I'm taking this in a couple of different steps. So this first step is we're just trying to turn a 3-degree taper with the bottom diameter just big enough to fit into the swivel jaw itself. We're not worried about it fitting inside the vise body yet. So that bottom diameter needs to be about 0.53. If we're a little under that, it's fine, but that'll tell us whether or not this taper is going to mate up with the walls of the swivel jaw itself, if it's going to give us a nice fit. And I didn't video me doing a test fit. I was constantly pulling it out and doing test fits and putting it back in. And I didn't want to have to remove the camera from above the lathe and then move it over to the bench and then put it back over the lathe. So, yeah. So it fit really well. And, that gives me the confidence that 3 degrees is roughly where we need to be. So now what I'm going to do is I'm going to turn that 3-degree taper until it's about 1.5 inches long. Really, it needs to go longer than that, but we're going to turn it till it gets about 1.5 inches so that we can check to see how it fits with the swivel jaw mounted onto the vise body, which means the bottom diameter there needs to be about 0.5 or 1/2 inch. So until we get to that point, we're just going to continue to turn the 3 degrees, and hopefully that's going to give us the length that we need based on that taper or that angle. So we'll do another test fit. And again, I didn't film the test fit. So the taper is still mating inside the bores or the sockets really nicely on the walls, but it's not long enough, and the bottom diameter is not small enough yet for it to fully go down to where the threading starts inside the vise body. So we're going to need to turn this taper a little bit longer and shrink that diameter of the end of the rod down a couple thousandths. So I have to work with the limitations of my lathe, and you can't tell here, but all of this is a manual operation. I'm turning a wheel all the way on the right hand side on the compound, which is the device that the tool holder is sitting on. So this is not an automatic feed process. It's all manual, and you can't do an automatic angle like this on this lathe. You have to turn them by hand, which also means that the finish on the part is not going to be as consistent as something that's done mechanically or automatically. So I've got my compound all the way to the right, and it only has like a 3-inch travel on it basically. So that means the longest taper I could turn would be 3 inches. So I had to move the bar out to the rightmost point that I can position the tool holder. And then I can move the tool holder all the way to the left, all the way up to the chuck if I need to. But this gives us the longest travel possible with my compound. And this is pretty standard for your hobby lathes, especially the cheap Chicom ones. So we're just going to check that diameter again and see where we are. And I'm constantly going back over to that vise body and measuring the inside diameter at the bottom of the bore right before where the threads start, just to make sure that I'm where we need to be. So if you haven't figured it out yet, we're actually going to have to take this entire taper and transfer it to the left on this bar, and we'll talk about that in a minute, if all of this lines up like it's supposed to. So that test fit worked out really well. So we'll move the compound all the way to the right, and then we'll line the bar back up. So I should have mentioned this at the beginning of the video, but this is mild steel. I think it's hot rolled, high carbon 5/8 bar, if I recall, that I got from McMaster Car, I believe. So I've marked the end of this bar at about 1/2 inch, maybe a little bit more. And we're going to line that mark up with the cutting tool at its rightmost position. If we're going to thread the bottom of this, we need to have roughly 0.7780 of an inch of length there, which means we need to take the entire taper and transfer it to the left. And then we will just turn down that very end piece to the diameter that we need to be able to put a 7/16 by 14 thread on there. So that's what we're trying to create, which means this section here is roughly 1/2 inch, and we need to move the taper to the left 1/2 inch. You get the idea. So I'm just going to put a mark here on the bar, and that's going to give us basically where we need the taper to end. Then we're going to go all the way down to this other mark. So that taper needs to be transferred up to there. So we'll start at the right side and turn there. And again, we're just turning that 3-degree taper. So once we've started this. All we've got to do is repeat this until we've moved the entire taper to the left. Now, in order of operations, there's probably, a machinist probably has a much better method of doing this, and a method that's less time consuming, less work. But I'm not a machinist, and this is me just playing around on my hobby lathe. So once we've verified that we've got that end diameter correct, now we can turn down this end that we're going to thread. So we've removed the 3 degrees from the tool and the compound. And what we've got now is a perpendicular angle. So we just need to turn this down to the diameter we need for that 7/16 by 14 thread. And to be honest with you, I don't recall what the outside diameter needed to be, but pretty simple turning operation here. And we'll just face the end of it. We'll throw a chamfer on there. That'll help us thread it a little better. Chamfer that step right there. And then we can take this over to the vise. And I've got really tired of messing with the cheap Chi-Com tap and dies from Harbor Freight. So I went ahead and bought this big gear wrench 114 piece ratcheting tap and die set. It's SAE and metric. It almost self-aligns. It stays very, very dead on center and straight. And it just a lifesaver. I can tell you right now, this thing is so much easier than those cheap ones that I've been using. Highly recommend it. I got it off of Amazon. It's their biggest set, but they've got like smaller sets. And I think it was just under $250, which for what it is, I think that's an excellent price, and it's an excellent set. It gets my seal of approval. So if you're looking for a tap and die set, that gear wrench set is the get. So now what we need to do is kind of just finish the outside diameter of the top portion. This is going to be the area that protrudes above the vise jaw, the swivel jaw. And this is the area that we're going to put a notch on it so that you can twist this in and then twist it out with a wrench. And just cleaning it up a little bit with some acetone, and then we're going to sand all this. We're just going to dry sand. The speed that I've got my lathe rolling at, which is like 150 RPMs for the feed and everything that we need for this type of steel, is not super fast, so there's no sense in trying to polish it, because I don't think I'm going to get most of those the tooling lines out of it. And this is where we had the catastrophic failure. So this is a parting tool, and I've got it projected way the hell out there, further than it should be. You can see the setup here. And this right here is a recipe for disaster, especially on a cheap lathe like this. So as I part, sure as shit, at one point, boom. And that literally broke the cast iron. So, yeah, we had to finish cutting that off with a bandsaw. Here we are with the vise and the jaw, and we're going to test fit it. We're going to stick it in there. Probably should have used a bandsaw to cut it off anyways. But that meant that I had to order a replacement compound. Not a huge expense. I think I got a universal one off of Amazon for like $120 or something, and no, it's pretty much the exact same thing as what came with this lathe. So now that we know that this pin is going to fit like we want it to, we're going to go ahead and notch it. Basically, we're going to create a 3/8 section in that top portion. So we'll start by chopping the sides of this off a little bit with this cutoff wheel and a Fordham. You could use a Dremel. And my original plan was to just go all the way down with this thing, but I didn't like the way the wheel was biting in there, and so I said, all right, we'll just finish it off with a hacksaw. So we're going to take it down to that line that you can see on there that I did with a Sharpie, and then we'll do the same thing to the other side. Now that first cut wasn't super critical, but this side is, because you've got to have it set at a width that a wrench will grab. And for this, I'm setting it up for a 3/8 wrench. And then again, use the hacksaw. And yes, I know I'm not going perfectly straight with it. Now we're going to finish those edges with some files and the belt sander. So we're just trying to get everything kind of square. You can see that 3/8 wrench fits on there nicely. And we're just going to clean it up a little bit. So we'll slap it back in there and tighten it down. So I may try to make the other portion that has kind of like a little handle to it and that is pinned onto it, but I don't know if I'm going to mess with that. We'll see. But that's how it's supposed to look. Good job. So that's going to wrap up this video. I hope you enjoyed it. If you did, please like and subscribe. In the next video, I think we're going to do some finishing on the ends of the jaws and kind of square those out, and then we'll be ready to paint. As always, I appreciate the support, and I will see you next time.